These are the frequently asked questions for Algebra 2 for Section 7.6, Day 1. And the first group of problems is just writing each expression as a single natural logarithm. And I'm going to go with number 15. And we have 1/3 and then we have parentheses. And that's to indicate that that 1/3, we quite frankly could distribute it through the parentheses, but we know we're going to put it back as a power anyway. So we might as well go ahead and do the parentheses first here. Addition in logarithm language is multiplication. So this will be 1/3 natural log of x times y minus 4 natural log of z. And then again, that 1/3 is actually a 1/3 power. So natural log of both x and y, we have to make sure we get both those pieces in there to the 1/3 power minus, and then we have natural log of z to the 4th by putting the multiplication back up as a power. Now, a couple of things we need to do here. First off, I have that 1/3 power, and I don't want to forget that that's actually cubed roots. So this will be the natural log of the cubed root of xy minus the natural log of z to the 4th. And then, of course, we have the subtraction, which is really going to be division. So this will be the cubed root of xy over z to the 4th for number 15. So that's all been condensed, all one nice natural logarithm statement. And then I'm going to go after number 16 up here. Problem number 16. We have the natural log of a minus 2 natural log of b. Almost forgot my n there for a second. And then we have plus 1/3 natural log of c. We have several different powers going on here. All three of these have a different power. The first one is to the first power, but then the next term we need to put that 2 back up there, so natural log of b squared. And the next term we need to put that 1/3 back up as a power. Now, 1/3 power is the same thing as cubed root. I'm going to go ahead and change that right now before we get too far with this problem. And now that I have all the powers where they're supposed to be, there's just subtraction and addition going on here, and we follow the order of operations, which means we work from left to right. So this is the natural log of a divided by b squared, because that's subtraction, but then multiplied by that cube root of c. So it will be the natural log of a cubed roots of c over b squared. Again, always following the order of operations. Then, problem number 19, let me make some room here. 2 natural log of 8 minus 3 natural log of 4. So just like in the last two problems, what we have to do is get those powers back up where they were supposed to be. So this will be the natural log of 8 squared minus the natural log of 4 to the 3rd. Well, the natural log of 8 squared is the natural log of 64 minus the natural log of 4 to the 3rd, which just happens to be 64. So subtraction means division. We are supposed to find the natural log of 64 divided by 64, which of course is the natural log of 1. Love it when things like that happen as you're going through these problems. Next up, we have number 24, which is solve the equation and then check your answers. I probably will not check the answers unless there's an obviously extraneous solution here for these. So for these problems, what we have to remember is that natural log is logarithm base e, because the way that we translate this into language that we can understand is by using that snail shell process to exponentiate. So this would give us e to the 4th equals x minus 1 over 2. And then it's up to you. If you want to slap a 1 down below here and then cross multiply to solve, you could do that, or do the normal steps, which would be multiply both sides by 2 and then add 1. Totally up to you. So this would give me 2e to the 4th equals x minus 1, and that's by cross multiplying, and then I'd add 1. So 2e to the 4th plus 1 equals x. And here's where we have to go back and look at the instructions and see, did they want us to round any of these answers? And in fact, the book does give a rounded answer for that. that would be an exact answer there. If we have 2 times e to the, and remember that's the second button and then the ln key, to the 4th, and then we have to add 1 to it, that's going to give us 110.1963001, and for some reason the book decided to go with 3 decimal places. Well, that's interesting. I'm not going to do that. I'm going to go with 4. So 110.1963 would be our x value. And again, you could plug that in and check it and make sure that that's going to work. Then 27 and 28. Those look a little involved, so let's take a peek at those. All right, again, we remember that that's really saying logarithm base e of 2m plus 3 equals 8. But we're not allowed to separate that 2m plus 3, that's why it's in parentheses. So if we snail shell this, we'll get e to the 8th equals 2m plus 3. And really this is just algebra because e to the 8th is definitely a number. So we would subtract 3 from both sides and get e to the 8th minus 3 equals 2m. And then we would divide both sides by 2 and punch that in. So e to the 8th, subtract 3 and divide the whole thing by 2. 1,488.9789, which would round to 1,488.9790 for number 27. So, like I said, kind of an imposing problem when you look at it, but really it just comes down to, can you use your calculator when you're done. Then 28. Natural log of the quantity t minus 1 squared equals 3. Well, that is the logarithm base e of the quantity t minus 1 squared equals 3. And by snail shelling, we would get e to the 3rd equals, and then t minus 1 squared. If you know the formula and have done that enough when you're squaring a binomial, you probably could just jump right to the t squared minus 2t plus 1. All right, now we have a problem because we have a t squared up there, and that means we're going to have to factor. So we take a look at this and we think, okay, how on earth am I going to factor this? I have to subtract e to the 3rd from both sides. Exactly, that's what you have to do. So that would give you 0 equals t squared minus 2t, and then we would have plus, and as our c value, 1 minus e to the 3rd. Now, why do I say c? Because this is not factorable. Nor can we solve this by completing the square. This is just obnoxious. So, unfortunately, that means the quadratic formula is going to need to be used, and that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to use 1 minus e to the 3rd as c in this formula, and that's going to give us 2, because minus a negative will be a plus. Plus or minus the square root of negative 2 squared is 4 minus 4 times 1 times, yuck, 1 minus e to the 3rd all over 2 times 1, which is 2. The good news is it's all under a radical, and so we can go ahead and punch it in and see what we get. And we probably will approximate this one anyway since it's so nasty. So we have 4 minus parentheses. We need 4 times 1 minus e to the 3rd. Now we actually could just go ahead and distribute that ourselves. So 4 times 1 will give us 4. And then we have 4 times negative e to the 3rd. Well, that's going to be 4e to the 3rd. So let me write down what's going on here. So that's really what we need to punch in. 4 minus the quantity, and then we have 4 minus 4e to the 3rd. And we get 2 plus or minus the square root of 80.3421476.9 divided by 2. So two answers here. 2 plus the square root of that answer that we just got, divided by 2. And that comes out to 5.48168, so 17. And then we have 2 minus the square root of 80.34214,769 divided by 2. And that is negative 3.48168. So negative 3.4817 when we do that problem. Now, that is just fantastic. And both of those solutions will actually work. So kind of strange to have to use something like that in the quadratic formula, but it works. Remember, the quadratic formula will solve any quadratic. Then number 67 says, what is all of that means? Well, that means we're supposed to condense this. So we think, all right, so that's going to be the logarithm of 33,000 divided by, because we have subtraction, 99, but then multiplied times 30. So let's see what all of that mess comes out to be when all is said and done. We have 33,000 times 30, but then we have to divide that by 99. And that is the logarithm of 10,000. Well, wait a minute. That's a base 10. 10 to the something definitely equals 10,000. And that something is 4. Pretty doggone cool way to write 4 right there for number 67. You know how I feel about those. I love those kind of problems. All right, next one up is 68. 68 is a reminder of composition. So we have if f of x equals 5 minus x squared and g of x equals x squared minus 3, what is g of f of 6 now? You certainly can do this the shortcut way, since this will probably be on the ACTs or the MCAs, whichever one you still have to take. And you can put the 6 into f, get an answer, and then take that answer and put it into G. But I'm going to do this technically the absolutely correct way, where we're coming up with the formula. So if I have G of f of x, it means here's G. And what I'm supposed to do is wherever I see an x, I'm supposed to replace it with 5 minus x squared. So this will be 5 minus x squared squared minus 3. So I need to write out my 5 minus x squared twice, make it a couple of binomials, so squaring a binomial, and see what that comes out to be, and then subtract 3 from that. So this will be 25, and then outside times outside and inside times inside are both a negative 5x squared, so that'll be a negative 10x squared. And then last times last would be plus x to the 4th minus 3. So I would go ahead and turn things around here and put them in standard form. X to the 4th minus 10x squared, and then 25 minus 3 is plus 22. And then it just becomes a calculator problem by putting 6 wherever you see an x here. So we need 6 to the 4th minus 10 times 6 squared would be 36, so we'd have 360. And then we need to add 22. So that is 958 for number 68. Again, if it's a multiple choice problem on a test, then put the 6 into F, get an answer, and then take that answer and put it into G of X. You'll get the exact same answer there for 958. Now, number 69. Number 69 could just be done by graphing. This one has, what is the positive root of y equals 2x squared minus 35x minus 57? However, my hope is that you look at this and say, hey, that's a quadratic. I wonder if that isn't factorable, because it is. All right, so what we need to remember is we need two numbers in the front that will multiply to 2, and those combinations would be 1 and 2, 2 and 1. Now in the back, we need numbers that would multiply to 57, negative 57 in fact, So you just try a few things and you realize, okay, 3 and 19, that'll give me 57. So let me try negative 3 and positive 19, and let me try positive 3 and negative 19, because I'm pretty sure it's not negative 1 and 57 or 1 and negative 57. And before too long, you figure out that you have a combination here that's going to work, that's going to give you the 35 in the middle, and the negative 35, I should say, in the middle. And that is right here, because outside times outside gives you negative 38, inside times inside gives you positive 3. So it's first and first, last and last. So when we go for the zeros in this one will come out to negative 3/2. They didn't want that one. They want the positive one. So x minus 19 equals 0, 19. That's our positive 0. So again, you could just put it into your calculator, graph it, and then find the zeros, especially if it's a multiple choice problem. That's it for this section.